Good morning, everyone, or evening or afternoon, depending on where you happen to be in the world today. Welcome to our webinar, Plate Handling Best Practices for the Plate Room and Beyond, which is sponsored by FPPA, a first for us. We're very excited about it. Want to tell you a little about Flexo Global before we get started. First of all, my name is Laura Hatch, and I am the owner of Flexo Global. We're an expansive information portal for the global flexographic printing industry. Our site is populated with technical articles, webinars, industry news, job postings, an industry calendar, a print glossary, and a comprehensive resource guide with links to flexo printers, converters, and suppliers around the world. In 2013, we had over 2 million hits on our website, making it the place to go to get your Flexo news and information, and the best part of it is that it's all free of charge. I'd like to cover a little webinar housekeeping before I turn this over to the FPPA and our presenter. First of all of you are on mute, so please be assured that you cannot be heard by other attendees. If you need to take a phone call, if you need to have a conversation, please go right ahead. You can only hear us, the presenters. During the webinar, please feel free to type questions into your question box, which is in your menu. They will be answered after the formal presentation if they are not covered during the presentation. And finally, and most importantly, this webinar is being recorded and will be posted to the Flexo Global website for viewing at a later date. We know you may have to leave, or you may find that there are others that you think it would be of value for them to see this. So once this is up and posted, look for the weekly newsletter, which will have the URL link on how to access the recorded webinar. And with that, I would like to turn it over now to the FPPA President, Dan O'Brien. Dan, take it away.
Thank you. Good morning. On behalf of the Board of Directors and the members of the FPPA, we'd like to welcome you to our first ever webinar. We are very excited to have Vreeland's Jessica Harkins today as our first presenter. The goal of the FPA is to educate our membership from ownership to our hourly employees. My personal goals as the president is to grow the membership. And the only thing missing right now is you. At the end of the slide, we will show you how to join our organization as a member or a supplier. Thank you, and enjoy our first webinar.
I'll take this over from here. This session is going to focus on quality control and best practices in the plate room, as well as plate care on press and after the run. Discussion topics will include configuring and analyzing quality control checkpoints, as well as proper post-run cleaning and storage procedures. Our presenter today is Jessica Harkins Harrell. Jessica joined Vreeland in June 2010 and leads the technologies team of specialists focusing on plate making, proofing, color management, and press side assistance. She previously was with ESCO as the FIQ supervisor, working with digital laser imaging, plate making, fingerprinting presses, and software. Before ESCO, she worked for Shock as a technical director, completing R&D on digital plates and curves. She is a graduate from Clemson University and from their graphic communications program. And now I'm going to turn it over to Jessica as we transfer my screen to hers. Hold on.
Hello, everyone. Thank you for joining us today. This presentation is going to review some techniques for plate handling, whether that be within the plate room or after the plates leave that department and go to the press department and on after the print to storage. So to start out, the purpose of this session is to review some ways that we can simplify the control checkpoint process within that plate department. We want to be able to create a checklist of regularly monitored control points and also give peace of mind that if there is a print problem, that it's not necessarily a plate problem, that there very well may be other places to look for that problem, and we want to cross the plate department off of that list. So in order to do that, we first need to determine what's critical when we make plates. I think it's pretty obvious. Obviously, we want to make good plates that hold dots, lines, and other elements that are formed well on that structure. It certainly needs to be a process that's repeatable every single time, every day with every operator. You're always going to have a bit of an operating window, but for the most part, you want to be able to know what that final plate is going to be when it's done in the process. And we also need to determine what components impact that plate making process. So there's an 80s band called Cinderella that came out with a lyric that's "You don't know what you've got till it's gone, don't know what it is I did so wrong." So I'm really hoping that that's not the case in the plate department, that we can set up some parameters to be able to best understand cause and effect within that department. Throughout the presentation, we're going to talk about some recommended tools. That would be a bench micrometer, a UVA meter, a digital thermometer, a transmission densitometer, a light table, and a 50 to 100 power microscope, and some sort of plate measuring device. There are a few different types out there on the market, but for the most part, they all do a very good job. Some just have different, some different features available on each of them. So as we look at this, we need to decide what impacts the plate room. What's going to impact creating good dots, lines, and elements on those plates? We need to look for equipment consistency. We need to look at the room environment and also raw materials. And then what type of commitment do you have from your operators and from your management team? I'm going to talk a little bit about best practices for each of those components. The first being the room environment. Number one is cleanliness. This is a big one. I know a lot of people take this very close to heart, but there's some people that don't do standard cleaning every single day. I would say, for the most part, we need to make sure we remove dust from the department, make sure we wipe down all flat surfaces, vacuum and mop on a regular basis, and that should really be daily, if at the least amount of time weekly, depending on production. The second piece that a lot of people don't consider is reducing the amount of corrugated or paperboard used within and around the plate room. Over time, as box lids and things move against each other, those corrugated and paperboard fibers can release into the air, and that creates a lot of dust. So obviously plates are transported and stored in boxes. That's important to keep light out. But at the same time, we should consider maybe keeping the minimum amount of plates in the department as possible. Something else to look at would be considering an extra filter on your HVAC unit to try to keep dust, lint, dirt down. And also putting in a positive airflow, positive pressure within the room in order to make sure that only, if you open doors or things like that, the air moves out instead of air being sucked into the department. Something else to consider in the room environment would be the temperature or the humidity setting for people making sheet plates. The optimal room temperature there would be 72 degrees Fahrenheit, and the optimal humidity would be about 45 to 55%. When making liquid plates, room temperature, again, should be about the same, about 72 degrees, give or take, and relative humidity there would be a little bit higher. These settings, especially for liquid, are important to make sure that you can hit that caliper of the plate consistently, because liquid does follow the liquid properties. It will flow more if the temperature of the room is hotter or colder. Most importantly, on liquid is probably to maintain that same temperature over and over again so that you know you're making the same plate every single time. So if we talk about equipment consistency, in the image there are all the major steps within the plate making department. We go from imaging to exposure, processing to drying, and post-exposure and detac. And all of these stages require a piece of equipment, and each of those pieces of equipment should have routine checks and maintenance done on them. So if we first look at the imaging stage, we should definitely schedule a routine preventative maintenance visit, whether this is a laser or a film output device. And I would say this should be done 1 to 2 times per year and should certainly be completed by a certified technician. Most of the time, those are supplied by the manufacturer of the equipment. The second check would be a visual inspection on every single plate that's made. As you take the plate off the laser or as you image a piece of film, make sure you take a look at it. It doesn't have to be a long check, but take 5, 10, 15 seconds, scan the whole plate, make sure there's no lines, dust, debris, scratches, or anything like that. The next step on an imaging best practices would be to run a focus and a stain test, especially on laser imaged plates. That would be 1 time per week, or if that visual inspection on each plate fails. The tools for this would be a transmission densitometer, so you'd need that to run this inspection. There's 2 reasons to run this. Number 1 is to check and to maintain consistency and to understand how consistent the device is. But number 2, it's also important that the operator really understands how to run this inspection or this check, because when there is a problem and they need to run the test, if they don't do this regularly, they may get confused on the results that they're seeing. So it's important from a training aspect to make sure this is done weekly. On the exposure unit, the UVA main and back exposure, it's important to weekly check the UV output of the device. This allows you to understand how the bulbs are performing, what type of output you're getting from those lamps, and also it will let you know over time when's a good time to replace those lamps, because you should be seeing some consistency throughout the life of the lamp, and then over time they'll start to fail. I would recommend doing this weekly. The Flint Group has actually made an iPhone or Android app that can be downloaded for free, and you can take these measurements, quickly put them in this app, and save that for later so you can see over time how those bulbs are performing. The second thing for exposure would be to do a temperature check, and I don't think a lot of people are doing this at this time. Similar to checking for the UV lamps, it's a good idea to measure the 9 points across the bed after a minimum exposure of maybe 5 or 10 minutes to see how hot the inside of the frame is getting. And also what this will do is verify that you have good air circulation. There's been a lot of older exposure frames where a fan goes out and the operator isn't even aware that the fan isn't working. So it might be a good idea to check this weekly. Again, document that information so you have a good idea of how the frame is performing over time. And you can do this with either a digital thermometer, with a probe, or an infrared type thermometer. Now, if we look at processing equipment, obviously there's many different ways to process a flexo plate. You have your solvent processing, you have thermal processing, and you have water wash processing. Not going to over-speak or over-talk my bounds here, but definitely check with your manufacturer of your equipment to make sure you're following their recommended practices. What I'm going to go through in the next couple of slides here would be just my general recommendations, things to have a conversation with your supplier on that. So To first talk about solvent processing, number one point to check regularly would be to monitor your percent solids of solvent. So that would mean how much polymer is held within the solvent. If you have too much polymer in there, you're going to get an inconsistent washout. So you may have to extend your wash times, and you may still not get anywhere because you don't have enough virgin solvent to clean out the plate. If you are not keeping that value very low, or if you have too little, you're going to waste solvent in that process. So the next thing to look for would be an inspection of the brush condition. You would need to look for damaged, chipped, or missing dots on your plate, having an extended wash time, or fuzzy looking shoulders or mid-tone dots. This could show dots that measure larger even than normal on a plate measurement device. Third thing to review on a solvent processor would be the wiping rollers. This would be on an inline unit. These are rollers that have more or less socks over top of the roller to help pick up any extra solvent that was left over after washout. So you want to look for pooling solvent or residue left on the plate. If you see that, if you see anything between fine text, it might be time to replace those socks. If you're looking at a water wash processor, checks to do multiple times a day would be to monitor the pH of that device. pH is maintained by the water hardness, the soap, and the polymer level within the water. Tools that are needed for that would be a pH meter, and the interval, in my opinion, the best place to start would be about every 3 to 4 plates, just to determine how much polymer is getting diluted into the water. Second thing to check on that would be the temperature of the water, because water that's too cold will not be able to wash away the unexposed polymer. Again, back to that digital thermometer, probably a very good thing to keep in-house. And interval for that, I definitely check that morning and afternoon. If we move on to the dryers, best practices for that dryer would be to check the dryer temperature. Temperature in the dryer should be somewhere between 140 and 145 degrees Fahrenheit. This should be done weekly, again, just to gather a good set of data and information. Again, if you notice that your dryer is running too hot, it could very well be that there's a fan that's out somewhere, and you want to document that information too. If your dryers are running too hot, they could distort the backing on the polymer. If they're too low, you may have a really extended dry time or uneven drying on the plate. And the last step, major step in our process here, the post-exposure and detact section. So definitely need to measure the UVA and UVC output of the post-exposure and detact unit. However, the UVC lamps are pretty dangerous, so you need to make sure you wear protective eyewear. And there's not a lot of people out there that have UVC meters, so I would definitely recommend working with your suppliers. A lot of times they can bring those in and check those for you, and that should be about every 6 months. Now turning over to the raw material component. Number one, probably the most important thing would be to acclimate the material. We're moving into the winter months where shipments come in on trucks that are cold. We want to make sure that we get that material in and get it close to room temperature as soon as possible. Definitely want to move that in from a warehouse at least 24 hours in advance into the temperature of the room that it's going to be worked in. Again, back up to about 70 degrees, and you want to let that sit in that room for about 24 hours. If we're talking about liquid photopolymer, general storage conditions should be between 60 and 100 degrees Fahrenheit, and it's really important to warm up that material to 70 degrees before you begin to use it. For sheet material, as you bring in each new lot of material, it's important to mic the plate to make sure it's at the proper gauge. That would come in for each box, and you want to make sure you use that with the bench micrometer. So you're going to record that information with the overall thickness, the lot number, and the date. So kind of going back and reviewing each of those different pieces of equipment, if we look at a 6-month checklist for reviewing, we have our laser or our film preventative maintenance. We should do a preventative maintenance also on the exposure, the processor, the dryer, and check those post-exposure and DTAC lamps. If we look at things that we should be looking at weekly, it would be, making sure that the department is clean, clean up all the surfaces of the floor, remove any excess corrugated or cardboard, run your laser focus and stain tests, probably best. I usually tell people do that Monday morning first thing when you walk in the door. And then also checking UVA output, so your main exposure output and temperature, documenting those, and the dryer temperatures. Honestly, if you just set this up as the first thing you do Monday when you start work, 7 a.m. Monday, whatever time it might be, it's really good practice to get into, gives you good data to follow, for the entire year. And daily, setting up daily checklists, cleaning the surfaces, verifying the room temperature is at the correct temperature and the right humidity. Would be great to document that information in case there's any issue. You can look back to the numbers from that day and say, hey, maybe this caused a problem here. And any of those raw materials that you're bringing in, checking the overall thickness gauge and recording the lot number of that. So now that we've verified that our equipment is in good working order, I want to review a concept for putting in place a control strip or a controlled checkpoint so that we can monitor this information over time. So if we add these checkpoints, we understand when things pass and when things fail. It's another way to understand cause and effect. As simple as it is, if you drop a glass, we all know it's going to break, or most of the time it's going to break. You might be able to get by on that occasionally. In the same token, if you make a plate that has a relief greater than 25 thousandths, you could very well end up with a plate that does not hold a minimum dot because plates were set up for a target relief of, say, 20 thousandths. So things like that, cause and effect, we get an understanding of what issues could arise if something in our process changes. So in order to create this checkpoint, the first thing to do would be to create a control strip. This control strip should be placed on every single plate, should be run as a linear file, and run at the typical line screen and resolution that you run in the plate making department. If you have multiple line screens, it's easy to set this up as a multiple line screen control checkpoint. I mean, that's not an issue. So if we take a look at this control strip, kind of look at each of the elements. So here we have fine text. This would be used for verifying imaging, washout, and main exposure. If we look at another element on here, I like to include just a standard 150% stain test. So if I do need to run a stain test, if I see something that looks, out of the ordinary, it's all right there and I can make it from my control strip. I like to add a 1% minimum. Again, this has no curve on it so that I can see if my plate is imaging clean, if my imaging and all of that is nice and clean. I don't expect that 1% to hold on the washed out plate unless I'm using a flat top dot technology. And if I'm using a standard digital plate without flat top, I include a value that would be equivalent to my dot fail point. So if I'm using a 5% bump on my highlights on a standard digital plate, I'm going to include a 5% tint patch in there. So then on the last element here would be tint patches for measuring on a plate measurement device. This would be a Betaflex, a QEA, a Troika device, something where I can put my finished plate on the plate measuring device and check the value of the finished dot size. I like to include a 10% because anything much smaller than that, and sometimes they're difficult to read on these devices, so 10% generally reads pretty consistently. A 30% and also a 50%, again, for the same reasons. They seem to read very consistently on these type of devices. So as I image this control strip on my plate, I'm going to, once it's done imaging, take it off, inspect it for, do an overall plate inspection, but also look at the solid areas specifically to make sure I don't have any of the laser lines that you see in the image on the screen there. If you see something that looks like it could be a problem, probably take the entire plate over to that light table and look at it a little bit more closely. But generally, if everything looks good, you're going to take that plate and move it on and do your main exposure. So we're going to do main exposure, process the plate, dry it, get it through the entire cycle. And then once we're done with the post-exposure and DTAC, we're going to actually clip that small control strip off of the plate away from the actual production images and follow the following steps here. Number one, we're going to measure the relief of the control strip. We should also measure the relief across the rest of the plate, but this is just a starting point here. So measure the relief of the control strip. We're going to take that small piece and quickly put it upside down on a light table, and using our microscope, take a look and see if we're holding that minimum dot that we imaged, the 5%, if we had a bump curve on there, make sure that that dot is holding on the plate. We're going to take the control strip over then and measure it on our plate measurement device. We're going to measure those 10, 30, and 50% patches, and we're going to record that information. There's many different ways for recording this data. Number one, you could use a simple Excel spreadsheet. You could use a FileMaker Pro database or something else, however you feel it's best to record this information. One software program that I found that's actually really easy to use is a web program called Zoho Creator. I made this quick little database online in about 5 to 10 minutes. These fields are really easy, drag and drop, and it's actually pretty inexpensive online. So if you're interested in that, it's zohocreator.com. But I made this database within Zoho, and I can document the date, my operator, the temperature and humidity of the room, plate type, lot number, gauge, all of those things we talked about earlier throughout the presentation. And then specifically for this control strip, I can document my relief. I can check yes or no if my minimum dot held, and then also type in numbers or type in the values for the 10, the 30, and 50%. There's no right answer for what those 10, 30, 50% values should measure, depending on your plate material, depending on your process, depending on whether you're running a flat top plate or not. Those values could actually vary quite a bit. What's most important is that for the material that you're running and the process that you're doing, that those numbers stay very consistent time and time again. The one other nice thing about this Zoho application is that they do even have an app for the phone. So I was able to download the app for the phone on the iPhone specifically and log into my account, and immediately right there was the database that I created. So I could, again, have exactly the same fields. My plate type is a drop-down list, so I could select any of those and have all of that information right there in front of me, right on my phone. So that could make it very easy for an operator as well. So documenting that information at the very beginning helps us to realize what those numbers should read. And then over time, we start to realize, I would say within the first month of setting up this program, you start to understand what values are usable and then where you should be concerned. When any of those points hit outside your range, maybe you're not holding your minimum dot, then suddenly you realize that there is a problem, and that's where you need to set the range of good and bad, pass and fail. Once you realize this, then it's important to develop an action plan for what you do if you do see some of those values that are outside of your target range. Probably most important of all, the operators will take the time to collect all this data. It's then really important that you take the time to go through it, understand what's happening in the process, and use it to make the production department better. So I would recommend scheduling a time either weekly or monthly to get together as a team and review this information. It doesn't have to be a long hour meeting. Just take some time, 15, 20 minutes, sit down as a group and see what's working and what's not working in the process. Now that we have our control strip completed and hopefully, taken the time to implement that in the process, something else to consider would be what to do when you're cleaning sheet plates. If you take your plate and you send it out to the press room floor and the press operator is running startup, doing setup on the job, some ink has started to stick to the plate, and he needs to clean the plate. I've seen this a lot where the press operators aren't really trained well in understanding what to clean those plates with. And that's probably just as important as creating a control checkpoint process in the plate room. So if we take a look at this, some things not to use when you're cleaning plates, either on press or after the press run, would certainly be nylons or a nylon bristle brush. And the reason for this would be it will pretty much destroy any fine dots or scratch your plate. If we take a look at any type of woven fabric, like a pantyhose mesh or something like that, and we take a look at the small dots that are now formed on these plates, the mesh can actually, or the dot can actually fit within the mesh of those pantyhose and literally rip the dot right off. You end up with a plate, especially in some of these fine stochastic or hybrid screenings. In the highlight area, the dots are kind of far apart. It's so easy to damage those dots. So we're going to take that to keep the dot from coming off the plate. Something that we should be using would be either like a Pomarco Care type pad or a soft horsehair brush, because those will keep an open fiber and they won't actually catch the dots. It won't rip anything off the plate. Something else to think about would be to keep from using any harsh cleaners. Shouldn't be using anything that you clean your kitchen sink with to clean plates. This could break down the material itself. So we want to make sure that we're using a different solution to keep from getting plate cracking, plate curling, or just general plate breakdown. So number one, we should always confirm with the plate manufacturer what's recommended. But generally, our number one recommended cleaning solution would be ethanol alcohol, 100%. On most plates, this isn't going to damage the material in any way. Second recommended cleaning solution would be 80 to 100% ethanol alcohol with up to 20% acetate. This is generally good for most solvent plates, but again, most important thing would be to confirm that with your plate manufacturer and also complete a swell test with any solution that you're going to use to make sure it's not damaging the polymer itself. Storage conditions, make sure you always clean your plates before you put them away. Store them flat and as square to each other as possible. We don't want to store them face to face, and we want to make sure that they're flat, nice and square, out of light in an envelope, and also potentially with some type of foam interleave so that they're not sticking together. If we're talking about liquid photopolymer, again, always clean the plates before storage. You want to use a detergent solution that's less than 140 degrees, horsehair brush, and make sure that those plates are completely dry before you put them away. Storage, again, keep those out of UV light as well, and we want to keep those in a dark envelope in a cool, dry, dark place. General storage conditions for all plates, you want to keep them out of a hot storage room, and that can cause damage to the plates, and also make sure that the storage conditions, again, have the right humidity and the right temperature. So hopefully, you can reuse those plates many, many times throughout the process. So hopefully that gave some insight into some ideas and techniques to use for handling plates, creating a good checklist to use on a regular basis in the plate department, and also some thoughts for how to clean plates and store them after use.
Thank you so much, Jessica. We're in the process of switching around, And we have a couple questions come in. We may get cut off here, but I want everybody to be assured we're recording, and this will be posted to the Flexo Global website. First question we had was, I use Cosmolite QE170 water developed plate. I'm starting to rerun several print jobs and would like to know the best system for storage of these plates. Is this something that you can answer now, or would you prefer to email that answer, Jessica?
No, I think this falls along the lines of some of the last couple of slides there. Definitely want to make sure that those plates are clean before you put them away, and then also storing them with some type of foam interleave, you know, the foam that's packed between the plates, storing that with foam in between once the plates are completely dry and in an envelope. They can be stored flat or they can be stored hanging on a system like that, for sure.
Okay, I had a question that just came in. Can leaving a water-based ink dry out a digital plate?
I'm sorry, can you repeat that again?
Can leaving a water-based ink dry out a digital plate?
Sometimes those water-based inks they dry pretty quick and they can be aggressive on the surface of the plate. So the biggest issue is if you leave the ink on the plate for an extended period of time, oftentimes you can't get the ink back off of the plate. So I would recommend cleaning that as soon as possible, if that answers the question.
Okay, I'm reading questions as they're coming in here. What is the range of UV output before changing the lamps for back exposure?
On that one, I know there's quite a bit of difference in liquid photopolymer and sheet photopolymer. So on the back exposure lamps, the most important aspect is what is your piece of equipment doing regularly? So that would be the reason for checking those lamps on a regular basis and seeing if that dips down over time. If you're still getting good floors and can maintain that floor consistently, that's good. If you're starting to expend your back exposure times way, way longer than normal, then definitely it's time to look at changing those lamps out.
Next question, what do you suggest to use for plate separation during storage?
Probably the foam that's packed in the plates as they're shipped in. So if you save that foam in a clean place, probably best to cut that down and use that as an interleave.
Okay, and our next question is, what would be the best solution with regards to storing leftover cut-off polymer plate?
It's important on that. So if that's still the raw material, we definitely want to keep that in the dark in a plate making box for sure. The difficulty in that, especially if you have odd sizes, is making sure that all of the pieces are supported. You don't want to have different pieces that are laying uneven on top of each other. So definitely I'd put it back maybe in its own special cutoff, you know, in a box on its own with cutoff sheets, and try to keep those as flat as possible, or keep some board in between those to keep them flat and level.
One last question. In the 80-20 mix of alcohol and acetate, what type of acetate do you recommend?
Oh, that I don't know. Just, I would say standard general purpose acetate, and I can get the answer for that if you send me an email.
Okay, and now we're kind of running out of time here. Let's see if I've got all the questions answered. What is the telltale sign on the press sheet that shows you that plates are underexposed?
I would think if a plate is underexposed, you're not going to hold your fine elements on the plate well. So you should be able to see that right off the bat as you're making that plate, especially if you start up with, you know, if you start to have a regular checkpoint throughout your process, you'll understand when those plates are not exposed completely.
Okay.
Because you're not going to be able to hold your fine lines, fine text, and small highlight dots.
I think I have covered all the questions. I'm not seeing anything else popping in. If anybody has questions, please feel free to email me at Flexo Global, and I will send those along to Jessica. I would really like to thank the FPPA and Anderson and Vreeland for sponsoring this webinar. And if you're interested in hosting a future FPPA webinar, please contact the Executive Director, Diane Schaefer. Her email is on the slide here. If you haven't had time to write it down, please let me know, send me an email, and I will get that off to you. I think I have some more questions coming in here. Would you like to take a few more?
Sure.
When measuring the caliper of a sheet plate, is it all about drying that determines this?
The caliper on a sheet plate, as that material, after the material is processed, I assume. Some of it depends on if you're making that plate digitally or flat top. A flat top plate is going to be slightly thicker than a standard digital plate because of the, essentially the oxygen inhibition takes off a slight layer of that photopolymer. So drying, your overall thickness will come back to a specific gauge for sure. So drying is an important factor into that, probably the most important factor, but you'll get a little bit of difference in gauge whether you're measuring a flat top plate or a standard digital plate.
Okay, another question. Is there a solution to stopping air bubbles from forming while getting too hot exposing?
Is this, I assume this is on a film plate, plate made with film. What we found over time is that a lot of those bubbles are not always created by heat, but it has to do some with the cross-linking of the polymer, and that's some outgassing that happens within the polymer itself. So some of that has to do with really getting the air out from underneath or between the film and the plate material itself. So we're working on those techniques regularly to try to figure out something to work there.
Okay, another question just popped in. Which is the recommended intensity UVC lamps?
That's going to vary quite a bit because there are quite a few different configurations on UVC lamps. Some of them are, you may have a full UVC drawer with standard bulbs one after each other, and you may have a frame that's got alternating lamps. So output on that may vary quite a bit machine to machine. The most important element there would be to monitor that and know when they start to degrade. The UVC lamps are actually pretty expensive and costly to replace. So most important thing on UVC would be to, if you start to see the value in those numbers go down, that it's time to start increasing the amount of time used for UVC exposure or DTAC exposure.
Okay, and one last question. What should be the pH value of water for washout?
That really depends on the plate material, probably somewhere above a 9.5 to a 10, depending on that plate material. Obviously, again, going back to the manufacturer, that may vary slightly, but in our case, somewhere above a 9.5 to a 10, 10.5.
The questions are pouring in. Do you have any recommendations on a good UVC meter?
There are a lot of different brands out there. Kuhnhaus makes some, and there's also some other different varieties as well. I can do some research on that and get back to anybody that has a question on that.
Another one, most manufacturers recommend changing bulbs at 600 hours. Can you get more, and how do you see users doing this?
It depends. Again, if you're checking your UV output regularly, I would say you want to keep those bulbs in as long as you can until you see your lamp life or the UV output start to degrade. So that really depends on really if the lamps are going bad at that point. So I would say if you're monitoring that regularly, you may be able to get more time out of it based on the UV output of the lamps and making sure you understand that number really well. Each frame is going to be slightly different, and the intensity of the lamps does not always correlate directly with the amount of time, so it's not like you can just add more time to exposure and get the same result if your lamps really starting to get weak.
One last question. You had mentioned earlier about a device used to expel or reduce dust during plate making. I assume they're asking, what is that device?
I mentioned adding an additional filter to the HVAC unit, so the air conditioner heating unit, being able to make sure that's filtering to its capacity. The other thing that I mentioned would be to make sure that the plate room itself has positive airflow, so that if you're opening any doors in the department, that air from the plate room is actually moving out instead of sucking any debris in from other rooms, other departments.
I think that, oh, here's another one. What happens when you use expired resin?
That may not cure properly. So if your resin is past the age limit there, it may not cure properly, it may not handle or have the same exposures as you expect them to. And also, it depends on how long it's been stored in the room. Do you know where that material has been stored? Has it been stored in the same good environment for a long period of time? Or, is it something that's more than a year or two old? Its properties just may change dramatically.
Okay, and one last question here. Do you have any recommendations for a good plate washer for pre-press?
There are a couple, if you're talking about the automated systems, there are definitely a couple on the market. One unit that we've been doing a lot of work with is the Ovid plate washer. It does have quite a few rotating brushes in the front and also air knife in the back, and can be used with a lot of different solvents. So if that's the question, an automated plate washout unit for post-washing, that would probably be my recommendation at this time.
And I'm not quite sure, do you have or probably use a micron accurate Dispro calculator?
No.
And I'm going to have this as the questions are pouring in here. Plate readers are expensive. Have you found an economical unit that is effective at measuring plates?
Each of those devices are that I showed in the picture there are all pretty good. Again, they've got different features. They range in price between about, I think, somewhere around $5,000 to probably $15,000, $16,000. The more expensive ones will track some of that data automatically for you over time. Some of the least expensive ones are actually smaller, portable, and may not do quite as much on the software side as far as gathering and storing that information. But yeah, there's quite a range of those. So if you guys are interested in that, just contact me directly and we can talk about specific needs of those.
One last question. Are there any plate washers for mounted plates that you are aware of?
I have seen plate washers for corrugated mounted plates. We actually manufacture one of those, or have in the past. So that's something that's certainly up for discussion. If you're talking about mounted on a sleeve, I do not know of anything like that.
Okay, we're going to wrap up our questions here because I think they could go on forever. I want to let our attendees know that if you have questions and they weren't answered, I apologize, but please send them to me and I will forward them on to Jessica, and I am sure she will get back to you. Again, many thanks to FPPA for sponsoring this webinar and to Jessica for being a terrific presenter. Obviously, there's a lot of interest in this topic based on the number of questions that came through. If you're interested again in hosting an FPPA webinar, please contact Executive Director Diane Schaefer. Her email's on the screen. I will email it to you if you didn't get it. And we have another FPPA sponsored webinar coming up on October 30th, 11 a.m. Eastern Daylight Time, the latest developments in flexo plate solutions for corrugated printing. And our presenters are from Kodak this time. If you register, as you know now, you will be receiving reminders a day ahead, an hour ahead, with instructions on how to sign in. We really thank you for attending this webinar. We hope you found it of value. Please remember to check the newsletter next week for information on where the recording will be posted. This will be available to everyone to view at a later date, free of charge. Thank you so much, everyone, and we will see you hopefully on October 30th. Bye-bye.